Hello CIS40A, this is the part 2 of week 1 lecture, and in this part I will go over topologies. So topology is really a network map. It is a type of map that defines the characteristic of the network. It would include the workstations, the devices, network appliances. It would also specify IP addresses to really show or illustrate how data would move across the network. So logical topologies would then indicate how data is going from one location of the network to another location of the network or leaving the network. Now there are some of the common type of topologies that you will need to know for certification and for this course. First, that will be a bus topology. And the bus topology just simply have the terminated ends wherein that computers are connecting on an unbroken cable running its entire length. So it will be a linear base where I would send data from this system for the first system up here down to the next system, and that next system send it to the server, and the server would then send it to the fourth system and then the laser printer. Now in the case that because it's going to flow down linear wise, the disadvantage of this is that if there is no fault tolerance, in that if this cable is not working, then we won't be able to transmit the data from one end to the next. And the data needs to be specifically addressed so that way it would know which system down the line would need to be able to receive the data. The next topology is going to be the star topology. And as it's indicated, you would have a central point, and then or it could be using cable or wireless, and all the other system would be connecting to that central point. So in the case that if I have a switch in the middle and I have 10 other computers connecting to it, that will become a star topology. Now in the star topology, you do have a single point failure in that if that switch or that central point is failing, or if it fails, then none of the other system can be communicating. So as far as troubleshooting goes, it is a little bit easier to troubleshoot. However, there would be some challenges in that it is a single point failure. You can add new workstation to it, that will be an advantage. And if a cable goes out, it doesn't take down the rest of the network, or a system might go down, the other system would still be able to connect. So here it provides you the advantages and the disadvantages. So for number 10, we wanted to answer the question, differentiate between physical and logical network topologies. The physical topologies consist of the physical arrangement and connection of your system, where the logical topologies, it would just illustrate how the data is moving across the network. The network can have the same or different physical and logical topologies. For number 11, it asks you to provide the drawbacks and the benefits of the bus topology. As we mentioned, the benefits would be it would be easy to install. There would be low cost. We don't have to spend too much money on the cable. The drawback for that is it would have the lack of administration. There's a lack of security. It is a single point failure because if that main cable is failing, then we won't be able to send data from one end to the other end. And there is a lack of fault tolerance. For number 12, as we mentioned, that star topology has benefits and disadvantages. The benefits are that you can add new computer systems or new workstations to that particular network. If a single cable fails, it won't take down the other systems because the other systems are connecting via their own cables. It is relatively easy to troubleshoot in the case that if something goes wrong on one of the systems, you will be able to really narrow down which system that's down. The disadvantages of using star topology would be that there would be higher costs in that we would have more cables. And there is a single point failure, which is the central device. It could be a hub or switch. That central device is going to be a single point failure. When we switch back to the notes, we would see the next topology would be your ring topology. And as it's indicated, the ring topology is when we would connect it in circular. We would have one computer connecting to the next, very similar to the bus, but at the end, we would loop it back to the first computer. It is very similar to the bus. The only difference is that the last and the first system is connected. It is a little bit more expensive than the bus topology. And back in the days, Sonnet would be representing what we would see as a ring topology. So here's the layout for the ring topology. We would start with the system. So the one-way ring is, this is, let's say the system 1, it's going to send data to this one. This one can pass the data to this one, and the third system is going to pass the data to the fourth system. Now you might have bidirectional ring where it would go, we can send it this way and then we can send it the opposite way. That would be more costly to do a bidirectional ring instead of unidirectional ring. So it's going to go from the first to the last and the last back to the first. The next topology would be the mesh topology, and this is commonly found. It is most common, and it does have a lot of physical connection per device. We can also have a hybrid mesh in that you would have a mixture of different topologies, and the systems are more interconnected. So as we transition, we would see mesh topology is phasing out. Now the challenging side of this is when you're looking at a single system like this, there are multiple cables that are going to go into that system. So the network interface card needs to be able to accept these cable connections or interface with the cable connection. So likely that you would have multiple network interface card, as each would have one per cable. So here it talks a little bit more about how they would be interconnected. So to go to our assignment, it would ask you what type of network topologies are rare in today's network. I believe the ring or the mesh would be pretty rare. You would see more hybrid. In the next section, it talks about point-to-point topology. So we would connect one system to the next system, like a router to a router, a computer to a computer, a computer to a switch. So a point-to-point topology that just build a communication path between those systems, and often you would see that it's used using serial cable. In the case of router, there can be implement different media between the routers. And then you might have a point-to-multipoint topology, and with the point-to-multipoint you can have one router connecting to 3 other routers, one server connecting to 5 other servers. So that will be one point connecting to multiple points, and as is illustrated in the images here, you would be able to visualize that. So for the next question, we can say that an example of a point-to-point topology, that would be a router to a router, a computer to a computer, a switch to a router, a server to a switch, and so on. For number 15, it asks you to provide an example of a point-to-multiple-point topology in a network. That will be a router connecting to multiple routers, a switch connecting to 5 other computers. So when you select the topology, some of the things that you need to really consider, number 1, that would be cost. Cost can go into cabling, to the maintenance behind it, to the hardware like network interface card or wireless adapter. The second area that you should consider is going to be the ease of installation, and the third is the ease of maintenance. So how easy it is to install and how easy it is to maintain over time. The 4 things that you need to consider is whether it's fault tolerance. Will it be able to survive in the case if something goes wrong? Will that impact a larger part of the network? And lastly, we want to consider the security requirement. So for 16, we want to indicate those points. Those are our consideration when we select the topology that we want to be able to integrate for the network if you're building a new network. And indicates that if you're expanding the network, you have to take a look at the existing network and how that can be incorporated with the newer part of the network. So for example, companies can expand the wireless, or if they need more devices and they need to add additional segment to support more users, the growth of the company, and so on. So going back to the notes, there will be a hybrid topology where it's a mixture. So you would have a bus and a star combined, a ring and a star, or a bus and a mesh, etc. So that will be considered hybrid. There should also be you would commonly see the wireless topology. Many companies would offer different type of access point for public, like visitor, customer, patients at the hospital, and then there would be an internal wireless access point for employees. So wireless infrastructure, simply you just use an access point to connect the clients to the network. Sometimes that can be ad hoc, where clients would connect to another client system in order to, without having to go through the access point. Like if I'm using my laptop and I would tether, right, using the phone tether, and so that would be an ad hoc environment. And wireless could be using mesh. So the connection of the wireless, the access point needs to connect to the larger network somehow. So that means that it needs to go back to the backbone. So it would need to transfer the data back to the main switch, which goes to the router, and that gets routed out. And wireless doesn't always have to be 802.11 standard. We can also use infrared or NFC. So you would see some other type of connectionless medium that's used for wireless. It also lists the advantages and the disadvantages of wireless. So for selecting topology for the previous question, we can refer to page 10 on our notes. Now, a term that you would often hear would be network backbone. And all the segments for that large network will connect back to the central backbone, which is going to be the major appliances that would handle how the data is going to be able to leave the network, like the router, and how data can enter the network. So the backbone needs to we want to make sure that it has high performance, it's fast, it has high throughput. So here illustrates the backbone. You would have these switches connecting the systems together, and then the servers connecting to the main switch that would go out to the router. The router would route the data out. For the segment, a segment is just a small section of the network, and it doesn't have to be small, it could be just a section of the network. And that segment needs to connect to the larger part of the network and then the backbone. So additional acronyms that would identify with the different types of the network, that will be CAN, Campus Area Network, and this is often you would see for universities, colleges, or even when you go downtown to Civic Center, you would see some of this, like the courthouse is connected to other part of the city. So there would be several buildings that would then connect together. And so when you're connecting for CANs, we would use fiber optic to go from one building to the next building. And it also could be how far across are these buildings. And so the physical, geographical characteristic of your network is really, we have to rely on the layout of the building and the distance also across for the building. SAN is Storage Area Network, and this is where we would have storage devices that would be able to, we can have high-speed access to it. We use it to manage our data, where we would store the data, manage the data permissions, and how data is accessed. So for number 17, you can refer to the notes for CAN and for SAN, Storage Area Network, for number 18. And this you can find on page 11 of our notes document. And this concludes my video on topologies and additional type of network. Next, I will go into cabling, which is video number 3. So please watch the next video for cables.